All right, we are into Unit 3. Um, this unit is going to be all about the periodic table. So we're going to learn about all the different, classifications and organization and really get into, all the information you can figure out about an element just based on its position on the periodic table. All right, so one thing I want you to just kind of think of in terms of going to tests and things like that is going forward, avoid Googling an atom. All right, I want you to just use your knowledge based on what we're talking about in this class on the periodic table. All right, so I can tell when this happens because you sit there and you start talking about things that we never even talk about in class. So avoid the temptation to Google an atom to be able to answer some of your questions, especially written ones. So, brief history of the periodic table. All right. Dalton and Newlands really didn't create a table. They just kind of organized the elements or grouped them in some way. Mendeleev is the one who's kind of coined as the father of the periodic table. All right, so he made the first periodic table. But his, as you can see, looks really different as compared to our periodic table. Looking at Mendeleev's periodic table in a little bit more detail, some things that he is coined for is using atomic mass to order his table. All right, our current table uses something slightly different. And he's also the first person to kind of create groups and periods based on the similar chemical and physical properties of the periodic table. All right, so we use similar trends in our current periodic table. He's actually got really close to kind of getting the organization down, especially to the point where he was able to leave empty spots. All right, he was able to predict where future elements would be discovered, and he was right. So here's the current periodic table and what it looks like, and this is what we use currently. All right, so you've got a copy of this in the back of your lab guide if you want to use the one from the book. This one includes a lot of useful information. We'll slowly build on what's there. All right, but some key differences between our table and Mendeleev's is that we use what we call periodic law to organize the elements, and that is done by atomic number instead of atomic mass. All right, there's only a few places where the atomic number and the atomic mass don't increase together, but that is important for the current periodic table. All right, our groups and periods are still organized by common physical and chemical properties, but the true organization and how these things differ slightly from Mendeleev's table is because we also use electron configuration. All right, that's that whole 1s2, 2s2, 2p6 sort of thing, and we'll get into some more detail. So, based on what you've learned so far, you should be able to say which of these groups of chemicals have similar properties. All right, so again, our elements, the properties repeat from period to period. All right, which means as you go from period 1 to period 2, the same element in that group or that column is going to have properties in common. All right, so all of these have properties in common. All of these have properties in common. Okay? So based on that, see which this list, which of those groups of, or those atoms listed are in the same column or the same group. So if you chose C, you were right. We've got lithium, potassium, cesium, and rubidium all in the same group. All right, these other ones you can tell are maybe not in the same group because you've got hydrogen, helium, and neon. Hydrogen isn't in the same group. All right, we've got oxygen, nitrogen, and carbon. Those are in the same period, not the same group. And then you also have, let's see, iron, cobalt, calcium, and germanium, again, in the same period, not the same group. All right.